Hello, and welcome to the TOSCA overview and update. We are thrilled to see so many folks joining us today. So I'm Dee Scher, I'm with OASIS. I'm joined by Jane Harnad. She is in the control tower for us today. A couple things to be aware of. We are recording the webinar, and we will be more than happy to distribute the recorded version as soon as we are done. You are welcome, and we encourage you to submit questions during the presentation. You can do that at any time. If you look at your control panel, you will see that you have a question box. So again, we will be taking those at the end of the presentation, but feel free to ask those while we are going. Okay, so we have two speakers with us today that we're really excited about. Chris Lowers, who is the CEO of Ubisity, and he's also the chair of the TOSCA Technical Committee. We also have Tal Liren. He is the principal software engineer from Red Hat and also a member of the TOSCA Technical Committee. So with that, I would like to turn it over to Chris. And once again, thank you so much for joining us.
Okay, thank you, Dee. This is, as Dee said, I'm Chris Lowers. I'm the chair of the TOSCA Technical Committee, and I will be talking first about what's going on with respect to the TOSCA standard, and then Tal will take over and give us an update on exciting activities in the broader TOSCA community and the TOSCA ecosystem. So let's dive right in. The first thing I'd like to do is make sure we're all on the same page about what TOSCA actually is, and hopefully it won't come as a surprise to anybody that TOSCA is a standard. Hopefully everybody is aware of that. But then the question is, what does TOSCA standardize? What is its domain? Well, TOSCA standardizes a language. In fact, it standardizes a domain-specific language. And what is the domain of TOSCA? It is the automation of lifecycle management of application, network, and infrastructure services. And that is the way we currently look at TOSCA in the TOSCA Technical Committee. Now, for some of you, that may actually sound a bit as a surprise. Most of you probably remember that TOSCA is an acronym that stands for Topology and Orchestration Specification of Cloud Applications. So how did we get from cloud applications to applications, networks, and infrastructure? And when did we evolve from orchestration to broader lifecycle management? Some of you may also think of TOSCA as a modeling language, or even as a standard that defines information models or data models themselves. And all of those are actually correct in sort of the history of what TOSCA has, of how TOSCA has evolved. And to understand how that evolution has happened, it's useful to look at the history of TOSCA and some of the milestones that we have gone through over the last couple of years. As many of you probably know, TOSCA has actually been around for a while. The original TOSCA standard was published in 2013. And the focus of TOSCA at the time was to solve really two problems or two shortcomings that existed in the technology space at the time. This was when infrastructure clouds first started gaining some traction. Amazon Web Services was gaining traction. We had OpenStack getting some adoption. And those technologies provided support and technology for automating deployment of those infrastructure components. OpenStack had a technology called Heat. Amazon used cloud formations. And both of those allowed you to deploy in an automated fashion compute, networking, and storage infrastructure. But the real value of that infrastructure comes into play when you actually deploy application level functionality on top of that infrastructure. And neither one of those standards helped you at all with that aspect of the automation. So TOSCA was first and foremost designed to address the application level orchestration requirements for infrastructure clouds, and then also importantly drive the infrastructure requirements based on the applications rather than the other way around. So it did start out with a focus on application level services. The second challenge that TOSCA tried to address was one of portability. Many enterprises didn't just use Amazon or didn't just use OpenStack, but had a combination of those. And what you wanted to avoid is to create automation technology twice, once for each of those platforms. So TOSCA was designed with the goal of being a portable technology that could be used with a number or a variety of infrastructure technologies. And so it's that combination of application focus and portability that was really the driver between the original behind the original version of TOSCA. Then over the next couple of years, as TOSCA gained some adoption, the technical committee made a choice to change the encoding that was used for the TOSCA standard. The original encoding was done in XML, which is a perfectly good standard. It comes with a lot of formalism and schema languages and tooling, but it is better for computers than it is for humans. And since TOSCA was designed to allow service designers or application level designers to create templates or blueprints using text editors, the XML approach really wasn't ideal for that. So the TOSCA technical committee changed or added an encoding of the TOSCA standard using YAML, which was a much more human readable encoding. And that led to the introduction of the TOSCA simple profile in YAML. And that standard was originally introduced in 2016. The other thing that happened with the simple profile is that TOSCA standardized a number of types or data models, as you could consider them, to help people get started with creating simple applications, and that those types we refer to as the simple profile types. So starting with TOSCA simple profile for YAML, the TOSCA standard was no longer just a language standard, but also included a set of standardized types that orchestrators were expected to be able to support. And that standard went through a couple of iterations. The most current version of that standard is version 1.3, which was just released earlier this year in 2020. Over the course of those iterations of that standard, something actually quite exciting happened. When the NFV community, the Network Functions Virtualization community, started to look at automation of deployment of virtual network functions and network services, they were looking at a technology that could help not just with the initial deployment of the network services and the deployment of the VNFs, but also with the ongoing lifecycle management of those VNFs, because the ETSI NFV community has requirements for scaling, for switching between what ETSI calls deployment flavors that deal with different load requirements for their virtual functions. There are healing scenarios that need to be supported, and all of those ideally should be automated. And the ETSI community was looking for a standard that would be able to express the capabilities for healing, scaling, and what have you, so that it could be automated using orchestration and lifecycle management tools. And ETSI decided to adopt TOSCA as the standard for expressing those capabilities in some of their standards. And that was an exciting evolution an exciting milestone in the evolution of TOSCA that actually caused us to take a broader look at TOSCA and look beyond application services, but also look at networking services and other types of services, and look at broader lifecycle management and figure out how to express those more cleanly and more in a fully functional fashion in the TOSCA language. And that has caused us currently to sort of take a look at the next version of the TOSCA standard, which is TOSCA version 2.0, which we're actively working on, and that is planned for late this year. May spill over early in 2021, but this will be an exciting new milestone in the TOSCA evolution. So before we talk about 2.0 and what's going on in that area, I'd like to highlight a couple of reasons for why we think TOSCA is actually an ideal standard for defining the full lifecycle automation for a variety of services, not just application services, but networking, infrastructure, and other services as well. And it's really, in our opinion, 5 high-level points. It's the fact that TOSCA is an open standard. It's the fact that it's model-driven. It has an extremely rich feature set. It's domain independent, and most importantly, it has a growing ecosystem behind it. And I'll talk just briefly about each of those 5 topics. The first one is the fact that TOSCA is an open standard, and actually this is a big deal. It's a standard, which means you're not going to be locked into a specific vendor. You have participation from people who come from different viewpoints, who may have different requirements, and so you have a richer set of input into the process of developing the technology and the standard than you might have with a vendor-sponsored technology. But more than that, it's the fact that the standard is evolved or governed under the OASIS umbrella, which actually makes it somewhat unique. OASIS is a huge organization. It has more than 2,000 participants across 6 continents. They typically, projects or standards in OASIS come to life when you have a number of vendors that have similar requirements for interoperability and for portability, and decide to create working groups to work on defining standards for their application domain. So it's completely member driven, and it is based on participation from the members. But what's important about OASIS is that the standards are open, meaning everything that's being done under the OASIS umbrella is completely open to everyone, not just the members. So as a non-member, you can download not just the specs, but also work in progress. You can monitor the mailing lists. And it's that openness that makes standards like TOSCA unique. Increasingly over the last couple of years, OASIS has also adopted an open source approach to standards under the assumption that standards are only as good as the implementations behind those standards. So increasingly, we're defining standards that are in parallel being implemented using open source projects, and then feed experience from that open source activity back into the standard, with the goal of making the standard that much better and that much more adoptable. So the fact that it's a standard is, in our opinion, a big deal. The other aspect of TOSCA that is somewhat unique is the fact that it's model-driven. And let me explain what I mean by that. I think we all are aware of the distinction between declarative and imperative systems, where a declarative system focuses on what you're trying to deploy, whereas a declarative system focuses on how you're trying to deploy things. So TOSCA was one of the very first declarative systems for deploying services. And what that means is that from a declarative point of view, TOSCA starts from a model that is a representation of the service that is intended to be deployed. And often people talk about that as an intent model, but conceptually, it's a representation of what it is you'd like to accomplish. TOSCA actually goes one step beyond that. The TOSCA language assumes that not only do you have that intent model, but you also have, at all steps of an orchestration process, you have an actual representation of where you are in that progression towards what it is you're trying to deploy. And you have a record of the end result that you come up with, where that record includes property values that store configuration. That record has runtime state, and that runtime state is accessible through TOSCA language constructs. We refer to that end model that is the actual representation. We refer to that as the instance model or the service instance model. And I think what TOSCA provides you by assuming that there is this instance model, it gives you context within which you can actually do more sophisticated lifecycle management functionality. For example, 2 things that are very important from an ongoing lifecycle management point of view is the ability to deal with exceptions or failures or faults. When you like to handle faults and events in an automated fashion, you need some context within which to interpret that fault. So you can have a chance, a fighting chance, that actually deal with that fault in an automated fashion. And something like the TOSCA instance model gives you that context to start dealing with faults and errors in a much more automated fashion than you might otherwise be able to. The second aspect, or the second benefit of that instance model, is that it is the starting point that allows you to automate MACDs, meaning moves, adds, changes, and deletions. And those, in some respect, are actually much more important than the original orchestration of a service. If you look at the life cycle of a service, getting the service deployed and orchestrated is probably 10 or 20% of the work. The remaining 80 or 90% is the ongoing management, where you make changes, you may scale the service, you may add some functionality or add components. If you want to automate that, you need to have some context within which you can start automating that aspect of the lifecycle management. And the TOSCA instance model, which is baked in or assumed in the language, gives you the context for starting to do that. And the other thing I mentioned is the fact that TOSCA has a very rich set of functionality. We could spend, and we probably will, we could probably spend a whole hour going over the unique capabilities of TOSCA. So I'll just quickly go over this, and we hope to do a follow-up session where we dive into more detail about the specific unique feature set of TOSCA. But in TOSCA, everything is modeled as a topology that consists of nodes and relationships. So we intentionally do not introduce domain-specific concepts such as VMs or containers or networks into the TOSCA model. Everything is generically a topology consisting of nodes and relationships. And by the way, the relationships are first-class abstractions in TOSCA. They have their own support for configuration. They can have their own state variables and what have you, similar to nodes. So the relationship support in TOSCA is a very important feature that actually enables a lot of use cases that otherwise would be hard to handle. And as I said, any domain-specific information in TOSCA is not in the TOSCA language or in the TOSCA meta model. It is in the types that you define or that the end users define using the TOSCA meta model. And it's the type system that adapts TOSCA to specific application domains. I mentioned the relationships. Relationships are very important in TOSCA. They're actually not necessarily between nodes directly, but they are established between requirements in one node and capabilities in other nodes. And the reason for that decoupling is the fact that you may not always want to establish relationships at design time. Sometimes it's important to establish relationships at orchestration time or at deployment time. And you may do that for modularity purposes. You may have a small module that deploys one component or one aspect of a service that needs to be linked to another aspect of a service, but you'd like to model or design those two aspects of the services separately and combine them and stitch them together at deployment time. So requirements and capabilities let you do that. Requirements also let you express for example, resource requirements that need to be fulfilled by the orchestrator at deployment time. And what that means is that in your TOSCA service templates, you can bundle the requirements for the infrastructure and specify those requirements, again, using the TOSCA language. So you end up with everything needed to deploy a service in one place, and you leave it up to the TOSCA orchestrator to, at deployment time, find the right resources to fulfill those requirements. And that's a feature that leads to a lot of the portability functionality of TOSCA. There's a lot, as I said, there's a lot more to this that we won't go into today, but we hope to have a follow-up session where we talk in a lot more detail about TOSCA functionality. The fourth benefit that I alluded to is the fact that TOSCA is domain independent, and that is a direct consequence of choices we've made in the meta model or in the TOSCA language themselves. The fact that we avoid using domain-specific information in the language and keep the language as general purpose as possible. And that has led over the last couple of years to adoption of TOSCA in a actually quite wide variety of application domains. I'm listing just a couple here. The first one is the infrastructure as a service cloud, which is the original use case that I've talked about. Network functions virtualization is an important use case that I alluded to that sort of perhaps helped accelerate, at least in the TOSCA TC, the fact that we do need to take a broader look at TOSCA in order to support a broader set of application domains, but also a broader set of lifecycle management features, which is causing us to expand the language into a new version 2.0. There's a couple more. One that is actually quite exciting is the fact that TOSCA is seeing a fair bit of traction for cloud native applications. And these are applications that are deployed using containers, using technology such as Docker, that may be orchestrated using Kubernetes, use service meshes. And there is a fair bit of interest in using TOSCA as the language to package those applications, but also express the relationships that you might see in a service mesh, and use TOSCA as perhaps an alternative, and hopefully a superior alternative to packaging technologies in the cloud native space today. And Tal will talk about this a little bit more in his section of the presentation. Software-defined networking is seeing adoption of TOSCA. We're aware of at least 2 or 3 tier 1 operators that are using TOSCA for management of their services, including software-defined wide area networking services. Functions as a service is a prime candidate for adoption of TOSCA. The definition of functions as a service that I like a lot is the abstract software application approach that is written without any deployment considerations. And TOSCA actually, by decoupling deployment considerations from the description of the service itself, it's an ideal technology for serving as a way to express the capabilities of functions as a service. And so we're seeing some efforts, some in the academic world, some in industry, to try to use TOSCA as a foundation for functions as a service. IoT and edge computing is another area where people are able to use TOSCA to express latency requirements for applications, which then may drive placement decisions, whether software components are placed in the cloud or closer to the edge. And using TOSCA, you can express those requirements and drive those placement decisions, all based on expressiveness of the TOSCA language. And then finally, one we're actually quite excited about is the area of process automation. This is the domain where automation is used for automating large manufacturing plants or oil refineries or what have you. In those environments, you typically have large networks of sensors, actuators that all need to get combined, and ideally dynamically, into systems that perform certain functionality. Those systems may need to get reconfigured based on events and load requirements. And we are seeing some adoption of TOSCA as the foundation for describing the automation functionality in that domain. So a wide variety of application domains that all use TOSCA in their unique ways, but all based on the shared functionality that is the rich functionality of the TOSCA language. So we're very excited about all of those. And then finally, I alluded to the fact that a fifth benefit of TOSCA is the fact that it's backed by a growing ecosystem. And we're just showing an example list of companies on the screen here that are either actively participating in the TOSCA TC, contributing to the standards, companies that are implementing TOSCA, companies that are using TOSCA for some of their technologies. And this list is growing, and we're getting more announcements day by day. We actually saw one yesterday from T-Mobile in Germany, who's using TOSCA for some of their technology. So very exciting to see the ecosystem growing. And in fact, Tal will take over at this point and take us through some examples of the types of things that organizations are doing with TOSCA. So Tal, over to you.
Thank you, Chris. So hello, everybody. I'm really excited to be here. I've been involved in TOSCA for quite a long time, and it's really a wonderful to see how far we've gone. A bunch of us are working on TOSCA 2.0 these days, and very excited about what's coming in. And as Chris emphasized, it's an open specification. I think we're a very, very friendly group, but also very argumentative. There's a lot of strong opinions, and I think it's a great place to come and make an impact and shape what TOSCA can be tomorrow. So what I'm going to do is overview some of, or a lot actually, of the currently active implementations of TOSCA. And I specifically chose implementations that are active right now. We have some historical implementations that have been around since TOSCA was really formalized in 1.0, and some new ones coming up. So I will preface this by saying that I've done my own research here about many of the products that I'm going to show you and many of the projects. If there are any mistakes there in terms of misrepresentations of what they are, I would like to apologize. They are mine. I did a best effort approach to really present them, and I hope I did not make mistakes. So if anybody involved in the project is here too, as well, feel free to add a comment, and we will make sure to correct it. Oops, so I will start. We'll go in alphabetical order here. And just to make sure that it's arbitrary and no specific implementation is preferred. So the first project I would like to present is called Alien for Cloud, and it actually has a sister project called York. And Alien stands for Application Lifecycle Enabler, or it's rather a contraction of that. And this is an open source project that is under very active development and active use. Chris just mentioned T-Mobile or T-Systems in Europe that is using Alien for Cloud to actually power their cloud topology designer tool for the open telecom cloud. Now, what's interesting about Alien for Cloud is that it has a kind of a two-tier orchestration approach, whereas Alien for Cloud, the product itself, is about high-level design of cloud topologies. And then it delegates the low-level orchestration work to another layer. So this layer could be York, which is the native orchestration layer designed for Alien for Cloud, but Alien for Cloud also supports other orchestrators, such as Cloudify, which we will talk about in another slide, Kubernetes, Mesos Marathon. So you can see there's a kind of a cloud-native approach here as well. An interesting aspect of this too is that the two kind of portions, the two layers are separate projects. So they're written in different languages. Alien for Cloud is in Java. York, the lower level orchestrator, is in Python, and they also have different variations of support. So York is much more in tune with the latest TOSCA. It's right now TOSCA 1.2, and I know they're working on TOSCA 1.3 support. The higher level Alien for Cloud actually uses a TOSCA variant. And we're going to see other projects also maybe not being entirely compliant with the TOSCA specification, but rather inspired by it. So yes, York can also be used independently of Alien for Cloud. Oops. Okay, here we are. So the next slide is about Cloudify. Cloudify is a company that has been around for a very long time, almost really since before TOSCA, and they've been early adopters of TOSCA, and in fact moved so quickly that before the TOSCA spec was ratified, they went ahead and created products for it. So they didn't really wait for the spec to come. What that led to is that Cloudify actually is not using TOSCA directly, but rather a dialect or variant of TOSCA, because they were building the product before TOSCA 1.0 and YAML really came out. Cloudify is an end-to-end orchestrator that targets many clouds. Its architecture is based on plugins. It's very plugin centric. So you can write plugins for Cloudify for various platforms, but there are also built-in plugins which are supported. Things like Chef, Puppet, Ansible. They're working in the NFV space, telecommunications with netconf, Kubernetes, and there are more. Another important thing to mention about Cloudify is that they supported, and this was a few years ago, but they supported an effort to create an implementation of TOSCA. And this was an Apache Software Foundation project. It ended up being retired, but I think the investment that Cloudify did in TOSCA ended up being very important. Personally, it was important because I was part of that project, and that was what really brought me into TOSCA as well. So, sometimes projects don't have a life in themselves, but they can be very important in terms of influence. So that is Cloudify. Dicer is a smaller project. It is a plugin for Eclipse written in Java, and its aim is to take UML designs that are more higher level and generate TOSCA from them. And what's interesting about this project, it was funded by the European Union Horizon 2020 program. And we're going to see a bunch of slides actually funded by that program or that received funding by that program. So there was a lot of interest, and that program was very important, I think, for the history of TOSCA and the activity of TOSCA right now. Eclipse Winery, so this is another Eclipse-based project, and currently in incubation, but the intent is to create a TOSCA modeler, that is a GUI that you could actually design the TOSCA applications, drag and drop them, and generate the TOSCA from them. So it is part of a larger project called Open TOSCA, and I think from what I can tell, this is the most active part of it right now. Again, it received funding from the European Union Horizon 2020 program, but also from the Federal Ministry of Economic Affairs and Energy in Germany. It is written in Java and, of course, parts in JavaScript for the GUI HTML elements, as I understand it. It has a dual license model that you can choose either the Apache or the Eclipse license for your work. So very interesting stuff. And they're also tracking the absolute latest version of TOSCA with 1.3. Enterprise Web is a commercial product that aims to create an application fabric with a very smart automation. So it has an internal automatic optimization of the application fabric as it's defined. It has a very rich internal unified object model that describes your entire application across its many layers. It supports TOSCA as well, in which case it consumes TOSCA and translates it internally to its unified object model. So TOSCA is used here as a way to potentially get information into your enterprise web deployment. This is a product written in JavaScript, but it is not open source. However, you can, there's a lot of information on their website, I think, to understand what they actually provide, and they work in many realms, including NFV. So this brings us to Etsy NFV. So this is interesting. This is not exactly an implementation of TOSCA, but rather a recommendation and specification for how TOSCA can be used in the NFV space. NFV, again, stands for Network Function Virtualization, and it's specifically used by the telecommunications industry. This is a very influential specification, and it's been, as Chris pointed out, important for the history of TOSCA as well, and the current adoptions of it. And we're going to see two more slides talking about implementations of this, actual uses of the NFV specification. Etsy NFV has been following the YAML specifications closely, so since 1.1, 1.2, now 1.3, and they are participants also in shaping, important participants in the TOSCA TC in terms of shaping TOSCA 2.0, which we're working in earnest on right now. Important too, we didn't really mention this, but one of the features of TOSCA is that it also has a packaging format specification called CSAR. CSAR stands for Cloud Service Archive. Yeah, Cloud Service Archive. And ETSI has adopted CSAR as a way to package network functions and network services. So it includes TOSCA internally, but you can, in the CSAR package, you can include arbitrary artifacts. TOSCA has a pretty strong framework for supporting arbitrary artifacts and attaching them to nodes. And we can talk about that in a future seminar. But ETSI is very thorough, I think, in its adoption of many TOSCA features, including service composition, etc. Itancho is a company, so this is another proprietary product. It is a multi-cloud network automation product, so again, focused on the telecommunication space. It supports open standard, it supports TOSCA, and it also supports Yang and other standards. The goals of Itancho are low-code architecture. That is, the idea is that users do not have to write code. In a way, it's the opposite approach of what we saw with Cloudify, where Cloudify is very plugin-centric and makes it very easy to write Python plugins to do the work. The goal in Itancho is to avoid writing code. Itancho is a very large collection of adapters and automations that you could use on different things. So again, you can consume TOSCA, it moves into Itancho, and then you can use their large collection to actually automate and support your various platforms. So many cloud platforms, many orchestrators are supported. ONAP is a very big one. So this is a Linux Foundation project, which is in some ways an implementation of the ETSI NFV specification that I mentioned. It is a very large project. Almost all the major global telecommunication companies and equipment vendors that you've heard of are involved and participating. It supports TOSCA internally. It actually, I think, includes 2 different or 3 different TOSCA parsers right now internally. This is a very large architecture involving many components that are in charge of different domains in terms of network automation for telecommunications. And TOSCA is used in many different parts of this. So ONAP is a very important user of TOSCA right now. And yes, I can go on for hours just about ONAP, but this is the high level look of what ONAP does. Open Baton, or Open Baton, depending on your pronunciation, is another implementation of the ETSI Mano specification. So this is much more lightweight than ONAP, the previous slide. This is much smaller, and it's also a bit older, quite a bit older. This has been supported by Fraunhofer Focus and the university, the Technical University of Berlin, and it's still in active development. But I cannot tell exactly which version of TOSCA they're supporting right now. But TOSCA is being consumed as part of the ETSI Mano support to implement TOSCA. So if you're looking at trying to orchestrate NFV and ONAP is a little bit big for you right now, Open Baton is a good starting point to play around with the technologies. Opera. So Opera is a general purpose orchestrator, and it's designed also to be lightweight. So this is also a great, I think a great entrance into using TOSCA and trying to look at how it can work with various domains. So again, Chris was emphasizing that TOSCA right now as a grammar is not domain specific. It really can support multiple domains. So I think Opera is a good way to start. It does have an initial focus on deploying on OpenStack, but I think the general way the program Opera is going is to really support any kind of domain. It is up to date with the TOSCA 1.3 specification as well. Again, supported by the European Union Horizon 2020 program. Open source, and I think a great way to start looking at TOSCA. Puccini is designed to be a general purpose TOSCA compiler. The idea is that it doesn't not only does it not target any domain, it doesn't target any orchestrator. The idea is that this is, if you need to add TOSCA to your product, why not use Puccini? It will handle all the TOSCA for you. And I'll point out that it is written by yours truly. So I have quite a bit of pride in this. The goal of Puccini really is to support all versions of TOSCA and to be very, very compliant and strict about it. In my own view, one of the great aspects of TOSCA are, on the one hand, its object-oriented design, which allows very powerful reusability of the meta model, but also it's a very strictly typed language. So that means that in many cases, when you do a design of a very big workload, your TOSCA parser would be able to validate that before you even try to deploy it, just to make sure that all the connections are good. So Puccini aims to do that very, very well. It is written in Go, but it has wrappers for a lot of popular languages, including actually WASM. So it can run within the web browser without any kind of server-side support. And yes, it's been around since 2018 and developed by a Red Hat engineer, which is myself. And I think, again, it comes with a lot of examples. And in my humble opinion, it's a great way to enter into TOSCA 2 and learn about it. TOSCA is a very lightweight project, and it specifically aims to be an orchestrator for Docker. So the point is, it's based on TOSCA 1.0, so it's an older version of the specification. But the idea is that you can compose larger Docker workloads using TOSCA. So of course, there are a lot of orchestrators for Docker. There's Docker Compose, which is part of Docker. There's of course Kubernetes that can do that as well. But here's a very lightweight and TOSCA-centric approach to that could be very interesting. One of the interesting aspects that Chris emphasized earlier is that TOSCA really approaches the day two work and trying to think about the instance model and what happens after you deploy. And I think TOSCA is a good example of this because one of its tools, TOSCArizer, tries to fill in the blanks that you have in your TOSCA from the runtime environment. So a small project, but a very interesting one. Turandot. So Turandot brings TOSCA to Kubernetes. The idea is really here to replace Helm as a packaging format to Kubernetes with using TOSCA. It comes with a TOSCA profile for Kubernetes that is modeling all the Kubernetes types using TOSCA instead of the Kubernetes low-level Kubernetes manifest. And there's a fairly good one-to-one correspondence. So if you know how to write Kubernetes applications, it would be very easy to move to Turandot and TOSCA and have all the benefits of Kubernetes, and I believe TOSCA too. So again, this was written by myself, so I humbly think that it is a good solution. It supports a lot of the TOSCA features, including multi-cluster workload composition. So you can define a workload that works on multiple Kubernetes clusters, and TOSCA has grammatical features that support that. And of course, it uses Puccini behind the scenes. So encourage you to look at that as well. And finally, we have the Ubisity orchestrator. And this is another commercial piece of software. And the CEO of Ubisity is Chris, who just presented before me. So I will be very nice and say that this is another excellent entry into TOSCA. Ubisity website also has an online TOSCA validator, which I think is an excellent way to play around with TOSCA and see if your TOSCA is valid or not, and look at the kind of errors that you get from it. So of course, being developed primarily by Chris, this is up to date with the latest version of the specification and already looking towards TOSCA 2.0. Ubisity is designed again to be a general purpose, pure TOSCA orchestrator, perhaps the purest of the entire list we've seen so far. The idea that it is not domain specific, but instead gives you the tools to add your own implementations for your own domains. I think one of its strong points is really the automatic workflow generation. That is, it can take your TOSCA topology graph and make sure that your workflow is efficient and generated both in order, both in parallel, and all the emphases that Chris said earlier about proper error control are built in then as well. So again, very much encourage you to check that too. And I think that's it in terms of me. And I would say again, I was really focusing on the big ones. I think the implementation list could be even bigger, and beyond that, there might be implementations that we do not even know about, and we would be more than happy to hear about them. And with that, I will pass it back to Chris to talk about the future. Thank you.
Thanks, Tal. And so that brings us to the final point we wanted to highlight, which is a preview of TOSCA version 2.0, which we have been working on for probably almost a year now, and inspired a lot by many of the projects that Tal just highlighted, and some of the requirements of those projects and gaps in the standard and in the language that were identified by trying to implement TOSCA for these various application domains in the context of these various technologies. And we'll schedule a separate preview of TOSCA version 2.0 with a lot more detail, but I just wanted to highlight a couple things that will be very different in TOSCA 2.0 than they have been before. As I said, in the TOSCA simple profile for YAML, the standard didn't just prescribe the language grammar, but it also introduced a number of data models, or types as we call them in TOSCA, specifically for infrastructure cloud deployments. And those types represented compute nodes, they represent storage, software applications to be deployed on the compute nodes, and what have you. And the standards prescribed that any implementation of simple profile in YAML was expected to support those types. And again, that was a nice way for people to get started and accelerate some of their initial TOSCA deployments. But if you're not working on a application domain that is cloud-based, if you're working on SDN, for example, or process automation, then having to implement those standard types may actually be more of a burden than a help. So what we decided to do as one of the big changes in TOSCA version 2.0 is completely decouple the type profiles from the language itself. So TOSCA version 2, the language, will actually be a pure language specification with focus on the grammar and all the functionality related to managing services. And then the type profiles themselves, including the TOSCA simple profile, will be moved into an open source paradigm with the expectation that those profiles will be maintained by the community and hopefully evolve more quickly than they would if they were evolved in the context of a standards activity. So that was one of the major decisions in 2.0. That decision identified some challenges in the language itself. It turns out that some language constructs assume the presence of the simple profile type. For example, if you're deploying on the clouds, you typically will deploy software applications that are then hosted on, in TOSCA language, on a compute node somehow, or more generally on a container. That concept of hosted on was one of the concepts that made its way into the language itself. And it's just one of the examples of how the assumption that there is a type profile sort of contaminated slightly the language itself. And we've cleaned up a lot of those contaminations and made the language a lot cleaner and a lot purer. We've also tried to adopt a much more cloud native paradigm to align with sort of current software development practices and deployment technologies, and positioning TOSCA to be the standard of choice, if you will, for cloud native deployments. And you'll see some of the elements of that in the language itself. And then sort of a third thing I wanted to highlight is the fact that if we're decoupling the profile from the language, there needs to be a way of easily incorporating new custom profiles, ideally, again, community maintained, but new profiles into the language. And we're introducing additional language support for supporting arbitrary profiles into the language so that it makes a lot easier to get started with new application domains using the TOSCA language. And these are just a couple highlights of what will be coming in version 2.0, but we hopefully will have a follow-up session later this year where we dive into the details of version 2.0 in a lot more detail. So that concludes the formal part of the session. We have one more slide here with information. These slides will be posted, so I won't go through the details of the information right here. But there are a lot of resources out there to help you get started. And if anybody is interested in actively participating in the TOSCA standardization effort, participating in maintaining some of the open source community profiles, or making some of their tooling available on the open source, there are links to the GitHub repositories and what have you on this slide as well. But TOSCA, just to recap, there's a lot of activity. It's very exciting. We're getting good contribution from a variety of people in various application domains, and we always welcome more participation. So if you're interested in participating, reach out to me or Tal or Dee or Jane, or just go through the TOSCA website and let us know. But we welcome all of you to become much more involved if you so desire. And then we'll have, I think, just a couple of minutes left for Q&A. So over to you, Dee.
So that was terrific. Thank you so much, Chris and Tal. This has been so interesting. We do have a number of questions, and we will take them. I'm trying to take them in order. Again, we appreciate you guys hanging in there. Feel free to drop off if you'd like. If you'd like to stay on, that's fine as well. Some of these are duplicative, so I will, again, try and consolidate them. You know, one of the purposes of us actually doing this today is we would love to get more folks involved to help with the heavy lifting of doing this work. As you can see, there's a significant amount of work that has been done and that also needs to be done because TOSCA is more relevant than ever. So let me just start with this first one. I had several questions about what you were going to do with 2.0. So I think I'm going to put those off to the side just because I do think that with so much interest, we should talk about having a follow-on briefing focusing on 2.0. So again, we will take that off to the side unless you guys strongly object to that. Is that okay with you, Chris and Tal?
Absolutely, and hopefully that last slide at least gave you a bit of a taste of what's coming, a teaser. But yes, we're in the process of putting together a much more detailed set of changes that we would love to present before the holidays.
Perfect. Okay, so here's just our first question, and I think probably you touched on this, but I'm not certain. So TOSCA superseded TOSCA TOSCA version 1.3 superseded TOSCA 1.0 XML completely? That's a question. Or have both been maintained in parallel?
That's a very good question. If you look at the text in the TOSCA simple profile for YAML specification, it actually states early on that the simple profile for YAML is intended to be an alternative and more human readable encoding of the XML spec, and that both of them would evolve in parallel. So that was the intent way back when in 2016. Now, since then, the XML version has actually not really progressed at all, and all the new features and the new functionality has been put into the simple profile for YAML specification, to the point where there is a lot of functionality in version 1.3 in the simple profile that is not in the XML spec. And in version 2.0, we're actually making a formal decision to completely decouple the YAML spec from the XML spec. So there is no equivalency between the XML spec and the YAML spec, and version 2.0 will completely stand on its own. And as far as I know, unless there is new interest in the XML spec, there is no activity going on in moving that spec forward as far as we know.
Okay.
I'll add to that. I'll add to that so one of the consequences of actually moving TOSCA to YAML was that YAML comes with its own data model. And that data model too changed between YAML 1.1 and YAML 1.2. I'm talking about the YAML specification version numbers here. One of my personal goals for TOSCA 2.0 was to decouple TOSCA's data model from YAML and to make sure that TOSCA as a specification could potentially really be implemented by other notations as well, or other formats. So TOSCA 1.0 to 1.3 in YAML did have ties to YAML specification itself, but with TOSCA 2.0, it will no longer be the case.
Okay, so here we go with this next one. If you are to design a single interface for deployment of services across different cloud service vendors, is it possible to implement this using TOSCA? And a little bit of elaboration on the answer would be greatly appreciated.
So let me take a stab at that, and Tal can elaborate as well. But so the answer is it depends. As you know, TOSCA was intended to be designed as a portable, or with the goal of allowing you to design portable templates across different cloud platforms. And for simple applications, that is actually possible. You can design a simple template that has compute nodes that you can deploy on OpenStack or on Amazon or Azure or Google Cloud Platform. So that is possible, and that was one of the goals for TOSCA. In practice, though, when you start designing templates or for services that are more complicated and more involved and include more components, you quickly run into challenges where just strictly defining one template that can be used across all of those platforms becomes challenging. To the point where it's probably not worth doing. What you would do instead, and TOSCA anticipates this and fully supports this, is you would have abstraction, meaning you would abstract out the common functionality that you'd like to deploy or the shared functionality that you'd like to deploy across your various cloud platforms. And you would create an abstract service template for that functionality. And then you would use decomposition, meaning you take each of the components in that service topology and you decompose that component, and that component is represented using a TOSCA node, but you would decompose it into its own topology using the TOSCA substitution mapping feature, where the substituting topology may be cloud specific, right? So you may have an application feature that you decompose using a Azure specific template. If you're deploying them on Azure, you might decompose it using a Google specific template. And that decision could be made at deployment time by the orchestrator, depending on what the available infrastructure is. So the language supports portability, but typically you wouldn't do it as simply as just creating one template that can get deployed everywhere. You would introduce abstraction and then use decomposition using substitution mapping to adapt the abstract functionality to the specific low-level available infrastructure. And that, I think, is best practice that we would encourage for creating portable templates. Tal, anything you'd like to add to that?
Yes, I would echo everything you said. I'll add my own opinionated answer here. The problem with creating generic models that would run on any cloud platform, I think that was a pipe dream. And I'll be very honest here and say that early versions of TOSCA sometimes had that negative connotation of that TOSCA is all about that approach. I don't think it is. I don't think TOSCA really was. But that approach hasn't really panned out because it's about creating some sort of lowest common denominator that would potentially work on any cloud. In my view, that was the wrong approach. That lowest common denominator ends up describing no cloud specifically and can never leverage the real advantages that each platform has. The correct approach, I think, again, is to model domains very, very specifically and using the full sets of features that those platforms have. The power of TOSCA, as I see it, that it's a grammar, it's not a type. And how it can help you in terms of portability and multi-cloud and multi-vendor and hybrid cloud approaches is not so much in that it gives you a single set of models for everything, but rather it's a meta model. It is a grammar, and it is a tool chain too. If you look at all the ecosystem that I mentioned here, if you have a standard tool chain to design things from your infrastructure to your network services, to your applications, to your database topologies, to your service meshes, these can all be different domains that have their own sets of types, including custom types that you design for your own applications, right? And their own specific logic. The advantage of having a standard tool chain for everything is enormous. You have a single way to validate all of these. You can have things, for example, like Eclipse Winery that gives you a GUI to design everything. A lingua franca in this case, I think, is enormous an advantage. It's a huge step forward in terms of moving us towards supporting very complicated, heterogeneous workloads that we see in many industries, especially telecommunications. To me, that's the big value proposition of TOSCA. Not so much having standard types, but having a standard grammar. So I hope that complements Chris's answer.
That's fantastic. So just a quick shout out, Cplane.ai is working on TOSCA for edge computing and process automation. We'd love to get you guys involved, John. So one more, I'm just gonna ask one more question because I think people are moving on to the next thing here. And again, if we didn't get to your question, we will follow up with you individually. I've got them all written down, so don't worry about it. So here's my last question, guys. What would be the perspective of using TOSCA outside of NFV domain? And again, I think you've talked about this.
Yes, that is actually something we would very much encourage you to do and should be very much possible. And to the extent that there's any friction in the language that makes that difficult, our goal with version 2.0 is to completely eliminate those frictions and make TOSCA even more domain independent than it already is. And so if you have domains that I haven't listed that where you would like to use TOSCA, by all means, reach out to us and we'll help you as best as we can. But this is absolutely something that's possible and absolutely something we encourage you to do.
Anything you would like to add, Tal?
Sure, I'll just mention that within the TOSCA TC, we have a number of ad hoc groups that work on specific topics. Some of them came and went. For example, right now there's an ad hoc group specifically looking at serverless. But I think a great way to join and participate is to create such an ad hoc group. And it could be very high level. It could be in terms of specifying requirements, providing example use cases, anything that can help the people working on the actual specification, if it's not you, to really fill in those gaps or reduce the frictions, as Chris said. And I'll also mention that our community website on GitHub right now, which is totally open to anybody on GitHub to join, includes a bunch of community contributed profiles. And right now there are things for Kubernetes, for OpenStack, for BPMN process automation. And it would be great to see more. And these can be examples of how you could model certain application domains or infrastructure domains, etc. We hope to see this keep growing.
Very good. You guys were terrific today. And again, I'd like to thank our speakers, Chris and Tal, and you guys did a great job. And thank everybody for attending, and so many of you hanging in there. That tells me what a compelling topic this is. We hope to see you more directly engaged with the work. As I said, there's a lot of work to be done. There's obviously a lot of adoption in TOSCA, and we're looking forward to future implementations and adoption and your participation. We will follow up with you individually. Thanks so much. I hope you have a pleasant rest of the day.